All right. Hello, everyone. This is our project proposal for assisted navigation for Telepresence robot. My name is Annie, and my partner Trang is also going to be presenting. So a telepresence robot is a robot that is providing assistance with virtual presence. So this robot will allow someone who is remote to travel around a workspace, also view their surrounding environment, and also allows them to communicate with nearby people. Some benefits of the telepresence robot is that it reduces the overhead of traveling. So that saves a lot of the money that comes with traveling, like airplane tickets, a lot of the time that is required with traveling, and also the energy. The a very difficult task that needs to be overcome with telepresence robot is the collision avoidance portion, where it has to navigate around objects.
This brings us to our problem statement, which is assisting navigation or navigation towards specific goal while avoiding obstacle autonomically, with supporting to the teleop that already exists. This will introduce the avoid of many obstacle for the robot to do it by itself when the user is using teleoperations. This could also reduce extra readjusting time that the user might need to do if they only based on the teleop. This could also improve the user experience, reduce frustrations, as well as require training and experience that the user need to have. The summary of the method that we want to bring into this project will be mainly the 3 circular regions to define the sensing area, including emergency, which is very close. The robot needs to stop. Assisted means the assisting regions where our algorithm will kick in, and safe area where the robot will just mainly follow the tail operations. We want to use a potential field method for our algorithm, and these whole project will be based on Unity raw simulations, and the robot model that we will be using will be Gopher nursing robot.
So some of the application impacts that comes with developing good collision avoidance in telepresence robot is that this will allow workers to do some remote work. So whether it is working from home or also saving some time from business trips, this will allow people to work remotely. Another application is that it will allow treatment for infectious patients. So this will protect healthcare workers so that they don't get sick from seeing the infectious patients, but still being in front of their patients and able to communicate with them. Another application is being able to consult specialized surgeons at the time of a surgery. So even though there's a very specific surgeon who is needed who's in Korea, you're able to reach them in the United States, and they'll be able to know the situation at hand. And then finally, this is useful for remote education. If there's a student who has a concussion, they can use a telepresence robot to remote into the school so that they have better immersion throughout their education.
Here's some of the research that we look for related work. The very first work is from on a natural assisted navigation motions. We'll go in more detail later on, but this basically introduced the 3 zone sensing regions. The second one that we base off is a paper on a shared control method for obstacle avoidance. This use a model predictive control method in which the robot will avoid the obstacle based on the linear constraint algorithm, but also predict the upcoming path the robot needs to take. This, however, result in a very little area explored based on the predictions, but require a lot more time of calculating, introduces more time and delay as well. In conclusions, a stronger and better computer would need to be used for a more efficient predictions as well as a faster time of computing.
So another related work was there was a Japanese research group that instead of using the three assisted zones, used the LiDAR to build a occupancy map. And when the LiDAR registers that an object is too close, the robot just stops its operations. So this is a bit different from our potential field method because it is using the LiDAR to construct an occupancy map.
This is a proposed method, as mentioned before. We'll be using gopher nursing robot. Our method is mainly based on the first paper that we read from Trang. Although our robot is not holonomic as the paper described in their experiment, we found out that our robot is a more commercial robot and ready to be used, which could also reduce in the cost. And our robot also come up with a laser scan, which provide a very good range of distance that robot could see, which will be very helpful for our algorithm. We'll be using potential field algorithms for obstacle avoidance algorithm, and as mentioned before as well, 3-zone distance, as you can see in the photos, with emergency region, assisted region, and safe region. And last but not least, it will be based off of Unity raw simulations with a provided hospital map.
So in terms of the experiments we'll be conducting, so we want to test that our implementation is correct. So the first very basic experiment is to ensure that the robot drives in the correct direction of the user input. And the second is that we want to ensure that the robot is operating with appropriate behavior based on the zones at which an object is located. So if the object is located in an emergency zone, then the robot should cease all operation. If the object is in an assisted zone, then the robot should kick in the potential field method and navigate around the object. If the object is in a safe zone, meaning it's very far away, then the robot should just operate using normal operations. We also want to do some testing on the robustness of the model. So under different environments, such as through doorways, narrow corridors, open space, and also having objects that are randomly scattered throughout the space. And finally, we want to compare our current methods with a very basic model, so benchmark testing, where the very basic model has all the driving and also stopping mechanisms disabled. So it's just user input directly feeded into the motion of the robot.
Yes. And for the simulations for hardware would be the gopher nursing robot, which is coming with the LiDAR and fast ray robot base. For the software, we'll be using Unity and ROS.
So for preliminary results, we were able to correctly configure ROS in Unity environments, and also we were able to load the gopher nursing robot inside of the Unity simulation. And this robot is able to be controlled through keyboard inputs. And we also used the hospital setting as our main environment for simulation. Beyond this, we were able to successfully communicate with ROS and achieve successful LiDAR sensing with ROS. And then we were able to read the LiDAR values through a ROS node. And finally, we're able to control the driving through ROS by sending twist messages.
Yes, some of the task divisions for the two of us. We already have done the research and background, as well as setup environment, version control, launch file, as well as creating a note. For the upcoming time, we'll focus more on the 3 different zones, as well as creating switch cases in more detail for our algorithm. And we'll be working together for potential field method for assisting zone, as well as preparing test environment. As you can see, we kind of divide it for every week. And last but not least, we'll spend majority of the time to test and record result and produce our final paper and final presentations. For this project, some of the objectives that we really want to learn from it would be the simulation of the Gopher nursing robot through ROS and Unity platform, as well as research multiple obstacle avoidance algorithms. We also would like to learn more and also achieve successful implementation of the proposed method that we have, including the potential fuel method, and also control the robot through ROS. We also would like to create and conduct robust test environment through Unity, and as well as learning more and working well with each other for this project.
In terms of deliverables, we want to deliver a successful implementation where the simulation kind of recreates the assisted navigation with the Gopher robot and Unity and also the ROS platform. Our baseline goals is to have the requirements for each of the sensing zones, which are the safe zone, assist zone, and also emergency zone. For our stretch goal is to test this model under dynamic and also robust environments through Unity. This can include moving the nurses, so that provides a dynamic environment, changing the hallway width, and also the room sizes to see what the boundaries are for the robustness of our model.
And thank you.
Yeah, thank you.